This is sample problem 1 on slide 41 of our chapter 13 PowerPoint. The question reads, write the equilibrium expression for the following reaction. And I have that listed below here. But before we start on that, I want to make sure we're clear on how to write an equilibrium expression. So a couple slides previously, slide 38 and 39 to be exact, we learned basically a generic equilibrium equation that we can use to show us how to write a equilibrium expression. So let's say we have random generic reaction A plus B gives you C plus D, and the little lowercase a, b, c, and d before our big uppercase letters represent coefficients like 1, 2, 3, etc. So to translate that into an equilibrium expression, it's going to be the concentration of the products. So these little brackets on my slide currently represent, basically they mean in units of concentration. Typically it's molarity, which is moles per liter. So for an equilibrium expression for a reaction, it would be the products, so in this case C times D, raised to the power of their coefficient. So that's why you have a little superscript C and superscript D up there. So it's the products raised to the power of their coefficients over the concentration of the reactants multiplied together raised to the power of their coefficients. So that's why you have concentration of A times concentration of B, both raised to their respective coefficient powers, A, lowercase a, and lowercase b. So now that we kind of have an overview of how to write a generic expression, we can go down here to where I've drawn the line to show, to figure out how to write an equilibrium expression for an actual equation. So, and we'll talk about this in a couple slides, we got to make sure we're either in the gas or aqueous phase. Otherwise, these are not included in our equilibrium expression, and we'll do an example like that in a second. But basically, we're going to follow kind of a similar pattern to what we did for the generic equation. It's going to be products raised to the power of their coefficient over reactants raised to the power of their coefficient. So in this, first I'll write K, and K is my equilibrium constant. It does not have units, but that's basically why we're writing this equilibrium expression. So we can solve for the equilibrium constant, which is particular to whatever reaction we're studying at that time. So on the top, we're going to put concentration of SO3, and we're going to raise that to the second power, and that's because if we look down here, we have a 2 in front of our SO3. And that's the only thing that's going to be on the top because that's the only product we have. So then we'll draw our division line, and on the bottom we'll put SO2 and raise that also to the second power because we have a 2 in front of our SO2 on the bottom. And then we're going to write concentration of O2. And we're not going to write a power next to it because it's kind of an understood one. We don't put a 1 in front of the oxygen in our reaction, so it's technically raised to the first power, but anything that's raised to the first power is just that same number. And so that's it. That's how you write this equilibrium expression. Sometimes you'll see K represented as K or K subscript C. C just stands for concentration. It's nothing crazy. So if you're following along on your PowerPoint, you might see K subscript C. It's the same as K. But this is your overall answer right here.